our seminar speaker today, Professor Joseph Sarkis. He had his PhD in management science from the University of Buffalo, and he's currently a management professor in the business school, Worcester Polytechnic Institute. His research interests are in environmental sustainability, technology, operations, and supply chain management. He has authored over 500 publications, appearing in a wide variety of outlets, and has over 8,000 citations. He served in several editorial positions, including many leading journals in operations, transportation, supply chain, and sustainability management. He's a former editor-in-chief of IEEE Engineering Management Review and Management Research Review. He's an international program coordinator for the Greening of Industry Network and the Springer Nature Greening of Industry Network's book series co-editor. He's recognized by the Web of Science as a highly cited researcher for each year from 2015 to 2022. He's a co-chair of the Future Earth Circular Economy Working Group, and he's also recognized as one of the most influential global scholars in general business and management. Oops. And with that, I would invite our seminar speaker to give his talk today, and I will. Okay, he's going to give his talk on blockchains and the circular economy, the opportunities and the challenges. And I would stop sharing this. And yeah, see if it's kind of advanced, okay? All right. So you're welcome, Professor Joseph Sarkis.
Yes, thank you. Thank you very much for introducing me. And thank you for being here, taking a beautiful afternoon out of your schedule to talk about circular economy. As you can see up here, we do have a National Science Foundation supported multi-year project to support students and learning in the circular economy here at WPI. It's called the Circular Economy Data Analytic Engineering Research for Sustainability Group, which we call CEDAR. If you're interested in the program, join up. There's some benefits associated with it. If you'd like to know more about circular economy from multiple perspectives, that's a good program for you to be more familiar with. I think we have somebody from manufacturing or material science, but I don't remember. Also up there are 3 of my books related to some of the topics. There's going to be another one coming out on circular economy and business issues with the Springer series as well. So that's a little bit of advertising for my books. All right, the agenda, and again, I don't know how much of this I'll be able to cover effectively. Some parts I'll go fast, some parts I'll go slower. The parts I remember to talk about, I will talk about. The parts that I forgot what I wanted to say, I will skip over. But you can see them on the screen. And at the end, hopefully we can have a quick dialogue going back and forth. We only have 1 hour for all of this, right? So I need to move it along a little bit. I put in there some SDGs and some of these other items. We'll go over some of those topics as we go along. But the way I like to begin this is what I teach. A lot of this is what I teach and research, which is greening and environmental sustainability. Now, sustainability is a much broader term than just environmentalism. If I asked you to raise your hands, what do you think sustainability? Most of you think environmental, but it's a more broader concept, which in some ways hides what I was really interested in, is environmental issues. The reason why is because sustainability has typically been defined as a triple bottom line: economic, environmental, and social concerns. When you add a lot of economic and social concerns, that kind of hide the environmental concerns. And that's the last point I have up there. Is sustainability good for the environment? But it also has an intergenerational philosophy. And this is where sustainable development comes into play. That what we're doing today should not hurt our future generations. This is the intergenerational philosophy of sustainability. There's many other definitions, and as we'll see, these definitions are also vary when you talk about the topic of circular economy. And the other topic that I'll be talking about today is blockchain technology. Blockchain technology, sustainability, how does those fit in? Well, we'll get into that point and how we integrate them in our research and my research as well. As I mentioned, sustainability is a big thing. The United Nations, the world, has adopted these sustainable development goals that we're supposed to solve all the world's problems by the year 2030. And there are 17 different goals. I touch upon these. I just want to bring them to your attention if you have not seen them. How many have seen them? Just as well, about 3 or 4. Good. So it's not a crowd that knows all about sustainable development, which is good. This is part of the learning process. So the sustainable development goals go from no poverty to where you might be interested if you're manufacturing and so on, is maybe into sustainable, responsible consumption and production. When you're talking about production, there's industry, innovation, and infrastructure. They have multiple sub-goals. I think there's like 170 or 200 sub-goals and metrics they use. It's materials development, education, social issues, life below water, life on land. I discussed a little bit of that a little bit later too. So remember the number 14 and 15. You'll be quizzed on all 17 of those. So if you don't remember them now, you're going to fail. Now let's go into more the environmental aspect of things. And I post these up there in my classes as a first class discussion saying there's multiple levels of analysis. There's multiple levels of the issues. You have clearly the global problems, climate change, global warming, ozone depletion used to be the biggest thing even before climate change. But we somehow solved that problem. Another one that we haven't solved and nobody's really talking a lot about is the biodiversity and species decimation. This is an area I'm moving into. Yes, a management professor talking about biodiversity. I think everybody should be talking about biodiversity because humans are part of that biodiversity. So it's an issue that I think needs to see a lot more. And of course, there's regional issues, deforestation, which affect the global issues, and very local problems, hazardous material waste disposal. All are environmental concerns, but they're also human concerns. If these things go wrong, the environment doesn't care. Humanity should be the one that cares. So the world, the earth is going to survive whether or not humanity survives. And that's another completely different lecture. And that's why environmental issues really affect any social economic concern in the long run. Now, inside the organization, some of you may encounter some organizations, there's corporate environmental management. And we have a listing of these different things. Because I teach it at a business school, I look at the corporate perspective a lot, organizations in general. Anywhere from what you would consider reactive approaches to meeting environmental laws and regulations to relatively more proactive approaches, circularity, measuring and managing carbon footprints. Life cycle analysis, some of you may have seen life cycle analysis in some of your design courses, for example. Products, materials, all have a life cycle. They have environmental concerns. And that life cycle analysis and environmental concerns also links to circular economy and blockchain technology or integrated technology. We'll come to those issues back to those issues again a little bit later. This is just background material so far. And one of the things that I do when I do an analysis and an evaluation and presentation of these topics is I always say I look at it from multiple levels of analysis. This is part of the systems perspective. Systems have input, outputs, but they also have level of systems. And we go all the way from very basic nano level issues, microscopic, molecular issues, all the way into global industrial networks. And yes, I have tried to publish at all those levels. That's why I have so many publications, because I could go at multiple levels of publication. But at each of those levels, if you're going to do research, you're going to need different tools and methodologies. So I got to learn a lot of different tools and methodologies. It's actually very fun. Areas that I never thought I would go into. And these are some of the things that are really interesting. And this is something I present in my green supply chain perspective. This is from one of my papers, and going through it, I show all the different aspects of how an organization manages its from manufacturing to its design, to supplier selection, to consumer marketing. And I offer a course right now that I'm teaching that goes through this whole methodology and different readings and cases as we go through that. So some of the topics, and I'm going to go very quickly through here, relate to upstream stuff. How do you manage suppliers, vendors? And we've developed research and identified different types of topics and so on. How do you manage energy? To make the supply chain, to make any organization, to make the world work, you need energy. Managing energy is central to a lot of sustainability concerns, as we know, whether it's climate change or pollution in the air, that smog that you get, or transporting yourself from location to location. Energy is probably the core issue of managing these whole processes. And we have a number of tools and techniques that we've looked at from an energy related perspective. Even blockchain technology in terms of energy trading, for example, might be something that could be considered. Additional topics inside the production, the manufacturing area. A number of issues that we listed. As a matter of fact, this is where my research and interest really grew in, because I was in operations management science area, PhD, and I was looking at the manufacturing. How do you go about making manufacturing decisions? What type of equipment would you purchase? What kind of criteria would you use? So I took all this multi-criteria idea of evaluating systems, or manufacturing systems, not necessarily from how much they could produce and all these technical details, but from more intangible values. Like, does it provide us the flexibility that we need? What type of flexibility? How do we measure all of that? Those are the ideas that I worked on as a PhD student and as a professor using multi-criteria decision-making therapy. So all I did was I said, look at, there's even more complexity here when you start adding environmental issues. How do you measure environmental issues in a manufacturing setting? How do you make decisions related to investments when you start bringing in environmental dimensions, like carbon emissions? How do you value a carbon emission? These are all research topics that have been addressed in some form. Like, what is the value of 1 ton of carbon going into the air? And they've got measures for those. 1 ton of carbon goes anywhere from $10, based on what they're selling it in Europe, per ton, to the actual total unknown social cost of maybe $249.23. I'll take that. No. I just threw that number out. But yes, it's in the 200, some group decided, yeah, the social cost of a carbon emission a ton is about $249 per ton. That's how much we should be charging companies related to making decisions when they emit carbon. Those types of things get into the designs that you may be involved in later. All right, distribution logistics, there's transportation stuff, waste management research. Now we're getting into the end of life of materials. And this is where I'm going to be talking a lot about today. I don't want to call it waste. There's no such thing as waste, by the way. This is an old diagram. Nothing should be a waste. Everything should be able to be reused, reconfigured, redesigned in some way that it stays within the system. Nothing gets thrown out. We live in a closed system here. Even the stuff that we throw off supposedly in landfill is still in the earth somewhere. And maybe years from now, somebody will be mining it to say, look at all this valuable stuff everybody's throwing out. Why did they throw it out? It's a gold mine. And there's actually people who are looking at urban archaeology that would go through landfills and determine what materials have been occurring. And they can actually design what materials occur at what level of a landfill. And they could mine it. We need plastics. Oh, we need iron, with a certain type of thing. Oh, that's about 300 feet down because everybody was throwing their iron away and it's buried in that. So you see, this urban mining idea is part of a broader circular economy. Now you're talking about municipalities. And there's money to be found in those landfills somewhere. Whoever owns that land is going to be very rich someday. Not today, but soon. Of course, they were getting paid to dump stuff there before. Now they can go mine it later. Another aspect from a supply chain perspective is this aspect here, which is reverse logistics. This is closing the supply chain loop. Before, everything that I've talked to right now is considered a forward linear supply chain. It becomes more environmentally sound. When we close the loop, it becomes more of a circular system or a circular economy in this case. This is only one supply chain, one type of situation. There's probably hundreds of additional topics that are covered in those areas. And it all begins and ends, by the way, in the product and process design. Again, what materials, what processes, how do you market to consumers to start buying things that are green? Those are issues that organizations have to deal with. Those are issues that designers have to deal with. How do you design a recycled product or material that works better and looks better than virgin material, for example? Can you do that? If you can, you have an advantage over the virgin material product because now you can sell it to consumers on being a green product. And this is how circular economy can be helpful from a competitive. And I have a whole discussion about how do you go building competitive advantage using sustainability issues. And there's also boundaries here. That is when you're designing a supply chain, when you're investigating any one of those principles that I put out there, suppliers, materials, transportation. There's multiple constraints. I call them boundaries here. Some of the boundaries are hard boundaries, depending on the level of analysis. Some of them are softer, ambiguous boundaries. So for example, I mentioned here 9 different boundaries. And notice, a lot of these are very soft, quote unquote, soft sociological boundaries, political boundaries, legal boundaries. You have to stay within some of those or understand them to be able to design these types of systems. Circular economy and blockchain fit within that context. And I have here a technological boundary. And that's the one I'm going to go into a little bit in depth. I have a theory there. Proximal boundary. Oh, the temporal boundary is very interesting too. Let me just throw a little thing there. One of the problems that we face as a society is time, temporal. Some of our problems are very short term. How do we design this product so it goes out to market? I think that's short term, even though it's 5 years. How do we stop climate change or man-caused climate change? How long have we been working on that? At least since the 1800s, or knew about it since the 1800s, since during the Industrial Revolution. There's early writing related to, look at all this stuff we're putting into the air, it's going to cause a greenhouse effect. That idea has been around for at least 5 or 6, 7 generations. And we're still talking about it. We're still trying to solve the problem. But the problem is not a short-term problem. This is a multi-generational problem. So you see the solution to a design for a product is going to be very different than a design of a new environment or a new industrial system. And that's what I mean by temporal boundaries. How do you consider those boundaries? And of course, there's also flows, in, out flows. We have the material, service, financial, information, waste flows. And the ones that information and materials and waste are kind of the linkage here between circular economy and blockchain. Of course, you could look at different types of systems. Capital systems, investment, for example, would be a little bit different than a service type system or a materials flow. Financial flow is actually part of blockchain as well. So let's get into the circular economy, the first big topic here of the 2 topics that I'll be covering today. And as we said, circular economy includes a lot of factors. Now, you're going to want a definition of circular economy. And my answer is, well, it depends on who you ask. Some people will say it's just the recycling, re-engineering, or reuse. The re's are circular economy. Others will say, no, it's a little bit more than that. We'll see some definitions here. For example, byproducts or developing byproducts is part of the circular economy. That's where I learned it from. So instead of generating a product or waste and then paying someone to take that waste off your hands, can you take that material, that waste material, and make it profitable to your organization? So instead of it being a waste, it becomes a byproduct that you could sell off. So you generate more revenue and you save on the cost of taking that material that's paying someone to dispose of it for you. There's a double cost savings there. That is considered part of the circular economy. Servicizing is part of the circular economy. So instead of selling a product, you're selling a service. You always own the product, and the service is what you're selling. You're not selling a chair. You're selling an appliance that you can sit down in, a service of sitting down. That chair belongs to whoever manufactured it. And if they do manufacture it because it's a service, and they keep that product or material, they have to determine what they can do with that. They want to make that chair last that way as long as possible, so that people can sit down there forever and they can keep charging for the service. So who cares about planned obsolescence and making sure the chair breaks after 10 years of use? Because you could keep generating revenue off of it and you use less material. That's one example. There's many examples of servicizing. This is a famous diagram called the butterfly diagram by the Ellen MacArthur Foundation. And I put the word essentially contested concept up there. This is a political science term that says those who are selling an idea will sell a concept from their perspective. Now, circular economy. I'm an environmental person with sustainability. What perspective am I going to take? Clearly, the environmental side. We should be doing circular economy. It should all be based on improving the environmental sustainability of our society. But if I'm an economist, a very traditional economist, my perspective is going to be, well, this is a way to keep the resources coming so that our industrial systems are resilient. The same ideas, but a different perspective. And it's an essentially contested concept from many different dimensions. You could do it from a negative perspective too, by the way. I used it from a positive perspective. And in this case here, depending on who you ask, circular economy may be different things. This is what you saw the first diagram. This diagram here is by the Ellen MacArthur Foundation, big circular economy think tank. And they essentially say that there's two types of cycles here. A biological cycle, things are biologically can be brought into the system. And a technical cycle, materials, man-made materials, hard materials, materials that aren't organic, that can be whatever, they go into the environment, biodegrading the environment. They take it from that perspective. And notice here, they do have the reuse, refurbish, remarket, recycle. I had that in my diagram as well. My diagram is not as good as their diagram, though. It's much prettier. But that's marketing for you. And here's another definition of circular economy. And these are different practices and goals. It's called the Resolve model by the same group in McKinsey. McKinsey likes these acronyms. They're a major consulting firm, as you might know, that charges millions of dollars to CEOs to give them advice. But they developed this with the Ellen MacArthur Foundation. And notice the different aspects here. Recycling is in there with the looping thing and remanufacturing, but also the share the assets. That's part of servicizing. This is the sharing economy. It's part of what they consider to be the circular economy. Again, expanding the definition of what they mean by the circular economy. Regenerate renewable energy. If you got renewable energy, it's by definition circular. I got into a discussion with someone. I couldn't figure it out. I still can't figure it out. Why is renewable energy circular? Because once the energy's out, you can redo it again, supposedly. Take energy and make energy, more energy. I don't know. It's just some thermodynamic. Oh, and dematerialization is a really interesting one. This is reducing less. We kind of bring it into our little model later on. One of the big examples of dematerialization with the same costs are your laptops in front of you. I mean, when I was growing up, big computers, of course, lots of materials, lots of waste. There's different types of waste here, different types of materials, but it's still something that if you lose less materials, you have to dig up less. But now comes the question of how you design it to be better. And this is another perspective of a policy framework of what the circular economy is. This is one of the earlier ones, believe it or not, before the Ellen MacArthur Foundation. This is China's policy, economic policy. They took an economic policy at the national level. And they called it circular economy, and these were what they defined it as. So you see, depending on who you ask, what level of analysis, you can have a different definition of circular economy. And this, again, is based on some of the Chinese circular economy policy definitions at multiple levels of analysis, from the micro level, single object organization, for example, supply chain coming into mesosymbiosis. Another aspect of circular economy is that the waste of one organization could be the input for another organization. And if you place these organizations together and apart, you have an eco-industrial part that's with industrial symbiosis. So you're not throwing anything out. You're just taking what we used to call a waste here, a gypsum board manufacturer, a utility company that produces ash. That ash could be used as a raw material for a gypsum plasterboard company. If you place them close to each other, you have continuing material coming in, going right into the platform. That actually occurred in Denmark. In that case, you can actually design a system, a park of putting certain companies and certain manufacturers in different areas. And then there's the highest level, the macro level, and the broadest level. One of the things that we're looking at is this last one here, which is kind of interesting, using biological agents. This gets down to little bacteria being able to eat things. And I think Professor Powell is even looking at some of these types of topics. We had this discussion before. And then they can take that material from the bacteria, squeeze it by leaching, and the material will come out. The thing that they ate, the cellulose, maybe even a metal. In this case, it's rare earth metals, end-of-life materials. You have bacteria that can eat these metals, squeeze them out, and the metals come out. I don't know how they do that. I just remember it's called bioleaching. So you see the different levels of analysis and science that can be brought into here. And now going a little bit further into the circular economy are the different re's. We put this together saying, look, we start out with three of them: recycle, reuse, and reclaim. But then we said, there's different nuances here. And the more nuances we get, the more published we get. But at the very top there, the higher you go, the stronger the sustainability. Find out how to rethink, reduce, and remove the use of any materials that you'll need. If you never need the material, that's probably the most sustainable aspect you have. What's the most sustainable building? The one that's never built. Okay, that's the kind of idea that you get to do. This is from one of our papers, but we also say the gears that drive a lot of this are deobsolescence, that is lengthening the life of a product, dematerialization, using less material, and product service systems, owning the material yourself and making it into a service. If you put those three together, the motivations start to change. Dematerialization can be cheaper, less materials. Deobsolescence can only work if you do it as a service and still make money by keeping the product going. All those gears work together. There's other definitions as well. I can't go. I think I went into enough for you. Let's look at the technical aspect, eco-technical aspect of things. And I begin with ecological modernization theory, which says that technology can solve the world's problems. I say that with a cough, of course. But that is what ecological modernization theory says. And that's what a lot of people believe, and technologists believe.
I think there's some truth to it, but I also think there's a lot of limitations. Technology can solve some of the world's problems if applied correctly, but it's not going to solve all of them. But they say here, technology can decouple economic growth, which we all want to see, from environmental degradation, which we don't want to see. And what's the solution? Technology. It goes back to the IPAT principle. And of course, the IPAT principle essentially says that environmental impact, I, is a function of population, affluence, divided by technology. Our policymakers, our sociologists, or whoever makes the decision, going to focus on population. Gets a little iffy. You could reduce population and reduce the environmental impact by man. You can also reduce affluence. That gets into equity issues, inclusiveness. Who is going to give up their affluence? So everybody turns to the final solution, which is technology. That's the easy one. That's where our innovative minds can solve all the solutions. Not perfectly, but enough. That's the argument.
Of course, it's a much more complex argument from a philosophical perspective, environmental perspective, technological perspective, sociological perspective. But we get back into that when we talk about interdisciplinary reasoning to bring all these together. And part of that is the importance of poverty, for example, in the whole scope of things. And one of the technological areas that we've been working on is Industry 4.0, which talks about integrating digital technology. This is one technology that we've been linking, and I threw out papers. I don't know if we threw out our paper in Industry 4.0 and sustainability linking. But we've done some reviews about that. And Industry 4.0 is one of those terms, like circular economy. I could give you 5 different slides with 5 different definitions of what's included in Industry 4.0. It's a term that's evolving. It's a contested term. But one of the things within this context is the integration, the distribution of the information, the sharing of information, information technology. There's also robots, drones, transportation systems. We're looking at some of those technologies in a circular economy perspective as well. And that's where I'm going to go down to here is some digital technologies. And we did this with green supply chain management, but these are the same things that we're looking at for circular economy. We have a whole presentation related to regular information systems and the relationships at multiple levels, from decision support to expert systems. Even AI could be incorporated in there, but we didn't put AI. The 3 areas that we did in this paper, and I think we shared that paper with you as well, digitization and green supply chains. You could have said digitization and circular economy if you want to as well. I look at those as comparable in some ways at the operational level. And we gave different examples here. You have the Internet of Things, and in the middle is the blockchain technology one. I'm not going to go over details of those because we're going to get more details as we go along. But my colleagues, my former PhD students and other colleagues have been looking at some of these. And one of them is blockchain technology. I mentioned the linear system of communication across the supply chain. You manage the supply chain with information flowing through, as we mentioned before, and communications between different organizations. What we're saying here is the blockchain is distributed ledger. Everybody can access the information, supposedly. It's purely visible. What we're not talking here is public blockchains like Bitcoin, where everybody could see it and share trade and so on. We're talking more about what we call permission blockchains, where entities, if they're given permission to see it, can view the data anywhere, whether they're consumers like you and me buying a product. We can see the whole life cycle of a product, environmental issues too, if we want to. Or a supplier downstream who needs to know what our customer needs are, and they can view it and plan their systems. And if you have more efficiency, more visibility, you could do a lot more. And there's more here. Who's involved in this? You have different standards. You have smart contracts built into blockchains. I'm only mentioning a handful of these things. A smart contract essentially is an automated operation, which could be based on AI or any type of decision support system that says once an activity has been carried out and it's been proven by the blockchain, and there's different systems in Oracle that can prove it, individuals can prove it, the transaction occurs automatically. If we put a bid out for a product or material, and everybody bids, once that bid is met, it's automatically said, you got the order, the contract is made, just send it along. And we'll send the payments and all these other things. And the payments, of course, can be done electronically. We'll switch over 1 Bitcoin from our files here. What is it? 1/100th of Bitcoin for this product here, and you get it as a credit. So cyber currency works into there. Cyber currency can also work from an incentivization perspective to get people to change their behavior. If I have a little wallet here, and somebody can put it in, if I like return my plastic, I can get credits for it. That's incentivization, that's tokenization. And you can tokenize plastics, you could tokenize materials, you could trace these materials. So there's transparency, traceability, visibility. All of these are great advantages of blockchain technology, theoretically. Does one exist that can do all these things? There's some demonstration projects. It's the future. I look at it as more like the future rather than the current present. Although some would say, oh yeah, we've developed all this. I've yet to see a full-fledged working blockchain that covers all of these things in a supply chain. There's some that are very specific. So we asked some questions and did some research related to, and this is one of the first papers on this, how do we relate blockchain? What aspects, what capabilities of blockchain? Security, reliability of data, transparency and traceability, or smart execution? Those are the 3 major dimensions. If you ask somebody else what blockchain is, they'll give you 2 or 3 other dimensions. But we went through our research and said, these are the 3 major dimensions that we've seen consistently when people have defined it as blockchain. And we said, okay, these are the blockchain dimensions. So we asked a bunch of experts. How did we find these experts? These were company experts who were actually working in the circular economy. These were company experts that were working in blockchain and sustainability. These were academic experts. And we said, hey, oh no, this isn't that. I'm sorry, this isn't that. This is our different study, which is case study. We looked up case studies, so secondary research and primary research. We asked companies as well. And then notice here, we use the resolve model. These are the resolve aspects, and we defined those clearly. We coded them clearly, and we said, where is the greatest one? We were surprised that right now, in terms of practices and so on, optimize and transparency and traceability was the biggest issue back in 2019. It's already 4 years ago. So this is changing. And that the lowest one is using smart execution for exchange, we thought would be the most popular one. Because once you do an exchange, the transaction is completed, the smart execution occurs. But it wasn't. This is where we asked the experts in different industries. We are now looking at a different definition of circular economy. These here are circular economy performance metrics based on the European Commission's definition of circular economy. We have to be very specific on whose definition we're using. The previous one, you saw the resolve model. This one, we use the European Commission's metrics on what a circular economy performance is. And again, in this case, we added on a little bit more incentivization, and we separated transparency, traceability, and security reliability. So 4 dimensions based on the literature of blockchain capabilities. And now we ask the experts, and the darker the blue, the stronger they feel the application will be there from a performance measurement perspective. Why performance measurement? Because you can't manage the supply chain, you can't manage the circular economy
without having the right performance measures and data. We're arguing that and approaches. And the surprising thing here, incentivization and tokenization, they felt, was the strongest way of managing the performance of a circular economy. And why? And we said, oh, it's behavior. They're saying that you could use the blockchain to change the behavior. That was our argument or analysis of the situation. And all of these things, you can get people to reduce the food waste. You can, people recycle more. You can trade in the recycling of materials using incentivization and tokenization. So you could do this analysis, and we developed some model saying that this is the research relationships here, and this is what these data told us. So we looked at it and we said, the greatest blue is incentivization and tokenization capability, and the one that seems to get the most benefit is the darkest blue, which is up on top. This is a relatively simple, quick way of looking at two different dimensions and saying, this is what the research says, and we can hypothesize or make research propositions. I want to mention the COVID crisis because are we still in it? In some ways we are, in some ways we're not. But it gave us some lessons. And this is the relationship we started making. So we brought in COVID, resilience, blockchain, we said supply chain, sustainability, the crisis. All of these are lessons learned. And part of the lessons learned is building resilience. Blockchain and circular economy, this is where it comes from. And we're talking still about the residues of our poor supply chain performance. As you see on the news every day, as you go into your stores, as you try to buy a vehicle, as you try to buy a computer monitor, oh, you have to wait, months to get it because the supply chain is down. And that's because of the COVID residue. They're still affecting the supply chain and its resilience. It's also something that the circular economy can solve a little bit of. Why? Because the circular economy allows you to manage material flows. And you can localize these flows. So for example, if we need a chair, we don't have to go buy a chair, we could get it down the hallway to someone who doesn't need it. That's as local as you could get. Or if somebody's throwing out some kind of material, you go out there and recycle it in some way. Or if somebody's producing a lot of product that has excess materials of some sort, chemical that you can use, they might have it available locally. So instead of being thrown out, exchange it with another company that needs it. So there's a lot more variety and what you would call more open thinking of where you get your materials from and where do you sell your materials. And I put this up here from one of my articles related to what are some lessons learned? And there's lessons learned related to social innovations and technological innovations. As we know, half of our crowd is now on Zoom. Would this have occurred before COVID? Very unlikely. We would have thought it was impossible. But now it's almost expected. Our faculty here can't have faculty meetings unless we're hybrid. And we had a big argument about that because people like the convenience of it. It doesn't get into the open discussion that we can have later on these topics as well. So there's social innovations and technological innovations that arose. I brought these in from a sustainability perspective. And notice the circular economy, I say localization and adaptation or agility are two of the lessons. And this is what we did with our next study. We said, let's bring blockchain technology together with circular economy. These essentially are resources and capabilities. That's the theory, that this will lead to localization, agility, and digitization. All of these things can help build resiliency. And we went through and did a series. Okay, one more down. We went through and did a series of studies and we said, look, we can do localization, agility, and digitization based on the circular economy and blockchain technology. These are three items that we think will build resiliency
of society in general and the supply chains. So then we said, okay, now let's take this and make it officially on here. So we went through multiple sources of information during the COVID crisis and said, look at these different companies, different industries, different locations, and determine how well they're doing. And we did by 4 different researchers on BCT capabilities and resources. And remember, the capabilities and resources are, did they use blockchain technology? Did they use some kind of reliability? Did they use distributed ledgers? Did they have tokenization? All of these things, we kind of looked at a bunch of articles and stories and case studies and started coding a little bit. No one did everything perfectly, of course, but the more they did, and the other side, of course, we did the same thing with circular economy, based our circular economy. And we found a bunch of companies in different industries, and we said those that are using more blockchain resources and capabilities to the right here, and more circular economy resources and capabilities are doing better on LAD, localization, agility, and digitalization, which essentially means that they're probably more resilient. And that's what we came up with. So we got a bunch of propositions off this diagram, and we had about 22 different companies. This is very qualitative research. Of course, we also said there's limitations to it. And what we came up with was this, that these outcomes will depend on industry and size. We had different size companies, different things, different characteristics, and came up with this model that can be testable in different ways. That's the research question. Now, what are we doing? Well, from a blockchain and circular economy, this gets closer to home right now. We're looking at, oh, you can't see that up there. What does that say behind there? It says something about circular economy, circularity relating to safety. So now we're saying, let's look at the safety issue. This is getting social dimensions back in there. Why? Because lithium ion batteries, that's why. And Professor Young, I think, is doing lithium ion battery stuff, recycling of them. So we started working with him and saying, hey, you know, this is a circular economy because we haven't worked together. And I was brought in because of supply chain issues, and he was brought in because of fire protection issues. So what you have are fire protection, safety issues, and there was just much broader concern here. Because I do know, in studying the circular economy, that it's a very dirty industry. When you start taking apart metals and products and materials to recycle, you don't know what's inside there. There's bad things inside there. So safety issues become a concern. And we use lithium ion batteries because it's safety issues everywhere. They're burning up. You have all kinds of chemicals. You have to take those chemicals out. So we said, how do we manage it? So there's many different dimensions of safety issues, social, electrical dimensions, and so on, multi-criteria. And we said, this is part of the circular economy, and there's different concerns. So we did a study that just got published, by the way, in Resources Conservation Recycling, related to what experts believe were more important using a tool to determine importance. That's from my PhD student, Karen or Joanne Shen, and she's leading a lot of this effort. And we decided, okay, these were the different experts and what they believed in the different importance areas, using different tools again, part of the research. And we said, okay, how do we manage the safety concerns? And this is where the blockchain comes into play. Because you need to manage the data, you need to manage the performance, you need to manage all of these things to be able to know what's going on. If you don't know where the critical things that are messing up are, and you don't have accurate, reliable information, it's very difficult to manage it. Maybe in your local area, yeah, this is where the concern is. But if you have data from throughout the supply chain in a closed loop system, can you design it somewhere differently that may impact it somewhere else? You can actually run an experiment if you had a good blockchain to do that. So no longer are you running an experiment in your laboratory, you're running them across the supply chain, and you can get data everywhere. That's the ideal situation. Is it occurring right now? Probably, yeah. No, because you need a lot of stakeholders to be involved in this. But this is getting back to the safety issues. The circular economy and safety has been an issue that many have ignored. Again, this is a different perspective on the circular economy. I'm looking at it from a safety perspective now. I'm no longer looking at it from an environmental perspective. Safety is the driving concept here. But there's issues there that need to be addressed. We're back to the sustainable goals. These are the 17 that you guys are going to be quizzed on later. And I kind of relate those towards the end. And now what I want to do is just show you the latest research in the area that I'm working on, other than the safety concerns. That is a concern. Climate change. One of the things that we're working on right now is rare earth elements are critical for a lot of things we do, especially like magnets for, the windmills. Specific rare earth metals for electric vehicles are needed. Rare earth elements are necessary to address climate change issues. Can circular economy help with that? Especially when we're developing all these new technologies where the elements are rare. You know how much rare earth elements are, well, I say it there, are recycled? 1%. Why? Well, because they're so rare inside the materials that we design. They're very difficult to get out. It's going to cost a lot more money to get them out of those materials because they're so dispersed. To get 1 kilogram of rare earth element, whatever the rare earth element, you need like 1,000 or 10,000 hard drives, for example. Who's going to be bringing all those hard drives and doing all that processing to get out 1 kilogram? But the interesting thing is that the concentration of rare earth elements in those hard drives is less than what occurs in nature. You need like 1 million tons of rock to get that rare earth element kilogram. I don't know what the numbers are. I'm just giving you an example. So you see, there's concentrations of materials in the stuff that we use that's better than what occurs in nature, yet people don't think it's economically feasible to do that, which is kind of strange. Anyway, climate change materials. The second one is the one that I'm working on right now with circular economy and biodiversity. And look at that, ocean biodiversity and REE metals is kind of interesting as well. So not only is it part of the climate change, it's also biodiversity. And why did I put that up there? Because the Los Angeles Times said, oh, we're going to have these companies now drilling into the ocean or mining the ocean. What could go wrong there? We can mine the ocean all we want, right? Yeah, we don't even know what's in the ocean, biodiversity-wise. So why do we do that and spend a lot of money destroying the earth rather than trying to recycle something? Why not invest in developing a system where we don't have to dig into the earth and destroy ecosystems? I think that's something that we should consider. It might even be better and cheaper if we do that. We think outside the box a little bit. And I'm working with a colleague using blockchain technology with embedded environmental resources. For example, every product, every material that you have has embedded environmental resources. There's energy embedded in this. There's material embedded in this. There's carbon emissions embedded in this. The problem is we don't know what materials, there's land embedded in this. How do we value that based on those embedded resources? We know how much value it is based on cost, based on weight, but we don't know how much environmental resources and emissions are going through this. And we're saying, hey, look, blockchain can solve some of these problems. We have life cycle analysis, yes, but we don't know how accurate life cycle analysis is. And the data for life cycle analysis is not very good. Blockchain can solve some of those problems. And then the last one here deals with equity and incentivization. That the blockchain and the circular economy has a lot of informal economy. There's a lot of people who are dependent on developed country waste that they can mine to be able to resell. And usually it's those who have nothing else, the most vulnerable in society. How do we manage that? How do we give them a way of living without taking it all away? And this gets into the whole issue of, if we formalize the circular economy by big businesses doing this and managing it, what happens to those whose livelihoods had depended on it? And that gets into inclusivity. Okay, so we'll move on from there. Future questions, there's a lot of them. Research actions, study, teach, and outreach. All of us could do all of those. And be involved with different groups, different stakeholders, look at different perspectives. You saw multiple perspectives here. We call this transdisciplinarity. Work natural scientists and engineers with social management scientists with industrial societal stakeholders, NGOs, governments, communities, et cetera, et cetera. That's what we need to solve some of our most wicked problems. This is an example from a paper I did with two engineers, Professor Bergendahl and Professor Timko, to show how we three, a social scientist, business person, can work with a chemical engineer, relatively pure chemical and civil engineer who does different things. And we published this in a paper, and hopefully it'll be one of our more highly cited papers. And if you want to learn more, I'm teaching a course on this next year. It's over this semester, and I have a whole bunch of cases that cover a lot. Okay, that's my lecture. And now I need to have a dialogue. Questions for you. What do you guys think?
I have a couple of questions about, like, from conversation about incentive structures. I think you partially addressed the first one and at least presented some like empirical sort of data to support it. How does like the implementation of, I don't know, blockchain structures or whatever, how does that, can you help me understand from like a high level bird's eye view, how do those incentives differ from the sort of like market incentive structures that we already work with in a lot of our policy at various levels? And I think my second question is, in the body of literature and amongst colleagues and circles in this field, are there dynamic conversations about sort of inversions of those incentives in a sense of like, well, why don't we just regulate harder? Does that, or maybe is there hesitancy in those conversations because of the like political viability aspects?
This gets into, well, the second portion of the thing gets into, do we use carrots or sticks? And my answer to that is, I think we need a good balance of both. There's incentives that are perverse incentives that we don't know about that could go wrong. So we should be flexible enough. By the incentive system I was talking about individuals. Right now, an example is we put 5% deposit and return it. But what about things that don't have deposits, but they have value? What if somebody was to pick them up, and how could they get paid? How do they know they're going to get paid if we do this? What is the value that we can have? Can we subsidize that because we know the environmental damage? Can the government say, look, you're an NGO, we'll pay you 10 cents for every 8 cents that you give somebody else? And it's worth a lot more than 1 cent for that material. But they're doing it because they know that the long-term costs, the external costs, the environmental costs are very large, and society will benefit by those people doing it. And who can benefit from this? Well, what you need, of course, is a cell phone or a smartphone, so you can get the credit once you bring in the plastic. That's how the plastic works. And then you get the credit automatically in your system, so nobody has to deal with money. Because if you start dealing with hard cash, people get corrupt. Of course, there's also corruption in the smart phones as well. But there's ways of managing that and auditing it much more easily than cash that can disappear. That's at the individual level incentivization. Organizations being incentivized. One of the issues is that organizations don't know where the material is in the supply chain. Once they sell it, they don't know, but they have to recycle it. So then the question gets into is, how do you get that information? You incentivize people providing that. It depends on what you mean by incentivization. I see another class coming in. I have one more minute. Thank you for we could go on debating a lot of this all day, but thank you for the question. I'm glad that you were at least paying attention. So have a good day, everybody.